Hello, my name is Sylvie Trudel, and today I'll be presenting the cosmic introduction concepts and definitions. Those are essentially taken from the ISO 19761 standard. In this module, you will learn the basics of the cosmic measurement method. Now, namely the definitions and how to measure functional size with cosmic in a nutshell. This module is intended to give an overview of the method, and its content is not comprehensive enough to pass the cosmic certification exams. It only gives an overview. The topics in other modules, like Module 1, Why and When Software Sizing, is already available, and other module also can be viewed. Module 3, Management Information System Case Study Overview, Module 4, Real-Time Software Case Study Overview, Module 5, Cosmic Non-Functional Requirements, Module 6, Early Sizing Overview, and Module 7, the Estimation Process. Now, for basic concepts and definition, let's say we have a software system. Software system over a boundary has functional users and also persistent storage. Now, from functional users to the software system, there are data movements that will carry out data groups, and there's also data movements to and from the persistent storage. And this measurement we will do is based on functional user requirements, which are the requirements that define the functionality the software must provide. The cosmic method measures the functional size of a piece of software based on its functional user requirements. Now, functional user requirements are derived into functional processes. A functional process is an elementary component of a set of functional user requirements comprising a unique, cohesive, and independently executable set of data movements. Now, a functional process is triggered by an event from a functional user and leaves the software system in a stable state once it completes. What we need to know is that within a software system, there will be a certain number of functional processes. Suppose a FIR, because a FIR may lead to one to many functional processes. A FIR, high level, saying the system must manage reservation. Well, the derived functional processes could be create a reservation, display the details of a reservation, modify an existing reservation, cancel a reservation, and list reservation. So in that case, we have one FIR equals to 5 different functional processes. And what we will measure is at the functional processes level. Now, a functional user is a sender and or an intended recipient of data in the functional user requirements of a piece of software. Of course, there are more than one types of functional user. The first we can think of is the human user, of course, and there are also other software that we exchange data to and from, and it can also be engineered devices such as sensor and the internal clock of an FPGA, etc. So the boundary is the conceptual interface between the software being measured and its functional users. The data group, because a data movement carries a data group that is moved as a whole by a data movement, and that data group is a distinct, non-empty, non-ordered, and non-redundant set of data attributes, where each included data attribute describes a complementary aspect of the same object of interest. The data movement now that is applied within a functional process on a data group is a base functional component which moves a single data group. And there are 4 types of data movements. There's entry, read, write, and exit. The data movements are what the cosmic measurement boils down to. When a requirement demands a data group to be moved through the software boundary or to and from persistent storage, it is called the data movement. And data movement is the basic unit that Cosmic counts. The entry definition, the type of data movement that is called an entry is a data movement that moves a data group from a functional user across the boundary into the functional process where it is required. So that entry data movement, let's take an example. The user enters his credentials. The user credentials is the data group. The entry goes to user typing his credentials. That's an entry. And credentials may more likely having like 2 different attributes, user code and password. The read, a data movement that moves a data group from persistent storage into the functional process that requires it. The data movement that happens when the system reaches its memory and recalls a data group. Suppose we have in the requirements users' previous orders. Well, previous orders are in the persistent storage and must be read. The write data movement type is a data movement that moves a data group from the functional process to the persistent storage. Let's say you have the system updates the user address. That the user address is a data group that will be written by the functional process into the persistent storage. And lastly, the data movement type exit. It's a data movement that moves a data group from a functional process across the boundary to the functional user that requires it, such as display a list of some data group, calls the API, the system turns on the heater. So the data group could be, let's say, list some data group, then that's an exit. A data movement that happens when the data group is pushed out of the software boundary. It could be also just displaying data on screen, sending a command or data to a device, printing data, etc. All those are example of exit data movement types. Now, types versus occurrence, there is rule 15 in the measurement manual, where it talks about occurrences related to functional process. If a data movement of a particular type, let's say entry, read, write, or exit, occurs multiple times with different data values, when a functional process is executed, only one data movement of that type shall be identified and counted in that functional process. Example, if it says print 10 customers mailing label, well, there may be 10 occurrences, but it's only one exit, because it's what we measure is not the quantity of data that will be manipulated, but rather the size of the software manipulating that data. Therefore, the printing will be called 10 times, but it's the same exit that will be occurring 10 times. It's only one data movement. In that case, what is the cosmic size? Well, the cosmic size and cosmic function points, or CFP, of a piece of software is the total number of all data movements described in its functional user requirements. Let's look at an example. Suppose this single functional process that is described as follows. When the user enters his credential, the system displays a list of the user's previous orders. Then you have user credentials entered by the user is an entry data movement one cosmic function point. User's previous order, read from the database, it's a read data movement, one cosmic function point. User's previous orders, so this one is the same data group, displayed in a list, well, that's an exit data movement, one cosmic function point. So the cosmic functional size of this functional user requirements or functional process is 3 cosmic function point. We just sum up the 3. In this following example, which is generic, we've got 2 functional user requirements that are detailed into 5 different functional processes. What we measure is individual functional processes, and suppose that these 5 functional processes have been measured, then we make the total, and this project is 31 cosmic function points. So those 31 cosmic function points really represents the number of data movements. As an overview, we have the software system containing several functional processes. On the front-end side, there are functional users. On the back-end side, persistent storage. And this is where data from the users to functional processes is an entry. From persistent storage to functional processes is a read. From functional process to persistent storage is a write. And from functional process to a functional user is an exit. For further information, please refer to the Cosmic website for detailed rules, exception, domain-specific tips at https://cosmic-sizing.org. Yeah, indeed, Cosmic is a not-for-profit organization. All its documentation is available for free and is made by volunteer work throughout the planet. Version 5 is currently available in 5 languages: English, French, Spanish, Italian, and Chinese Mandarin. Previous versions are also available in up to 12 languages. There are also guidelines for business application, data warehouse and big data software, service-oriented architecture application, real-time software, and a number of case studies. Thank you. See you in next module 3, Management Information System Case Study Overview.